Hi there, and welcome to the video. This one's around optimizing costs of Snowflake with Alteryx and Tableau. So, to give you a quick introduction before we get into the topic as a whole, the person speaking to you is me. I'm called Joe. I've worked at the Information Lab now for just over 2 years, and in that time, quite a lot's changed. When I first joined the company, we only really focused on Alteryx and Tableau. We kind of sell the licenses for those products, and we also do consulting using those products as well. And it wasn't until recently we added Snowflake into that mix, so kind of completing our triangle of products, if you like. And really, for the purpose of this video, these softwares have lots and lots of capabilities, but Alteryx would be the data manipulation software, Tableau would be that visualization, and then Snowflake would be where you store your data, the database. And I guess before Snowflake, we weren't really able to kind of offer what I'd coined a full stack solution. And again, these softwares have other capabilities, so it's not just necessarily what I've kind of described here. But I guess when you think about any kind of data project or kind of, I don't know, kind of solution for a customer, data needs to come from somewhere. It doesn't just kind of float around in the ether. And that place would be the database. That's where you kind of store your data. Then we have Alteryx. That's our manipulation software. So you take your data, you might know you might need it in a certain orientation, a certain structure. You use the software to do that manipulation, to do that restructuring, before then pushing it into your visualization software, which is Tableau. And that's where you have your kind of your pretty end piece. That's where you have your bar charts, your line charts. This is what your stakeholder or your client might consume at the end. And of course, they see those bar charts, they see those line charts, but they probably don't see all that the back end stuff that happens to really kind of fuel those visualizations. And that's where Alteryx and Snowflake work in tandem to kind of provide that data that gives those key insights to the business. So that's a quite whistle-stop tour of kind of how we leverage those products. But what is Snowflake? It's a good question. And I think to really understand how we can optimize cost, it is worth kind of discussing the architecture of it. And essentially, Snowflake's split into 3 different layers. You've got your cloud services at the top. You have things like your security, your optimization, authentication. So, that's the part where access is given to different people, passwords, that kind of thing. Going down there, we've got your query processing. So this is when data is required. This is the section of the database that will kind of manage that query and decide where the query needs to go to get the data. And then you've got your database storage, which is essentially, you guessed it, where the data actually lives, where it's held. And when we think about cost, the only 2 layers we're really interested in is that storage layer at the bottom and that query processing layer. Storage is kind of quite simple. The more storage you require, the more space your data takes up, the more money you're going to pay. Databases have worked like that for a very, very long time now, and that isn't anything too groundbreaking. When you go into the query processing layer, though, that's where kind of the architecture or the unique architecture of Snowflake kind of comes into its own. And this is where you get this kind of pay-as-you-go kind of idea. When you do kind of any reading on Snowflake, you often find yourself kind of stumbling over the same kind of words like serverless or phrases like cloud-based. But actually, when you kind of read a little bit deeper, you realize that these words do actually mean quite a lot. For example, serverless, really what that's saying is you don't have to worry about buying a load of hardware, a load of physical hardware. Cloud-based really means, as this kind of picture shows, all of your data is up in the cloud. It's basically off premises. It's accessible from anywhere in the world. Before these kind of cloud-based serverless solutions, a company would have to buy a load of servers. They'd probably have to then think about where they're going to store those servers, probably a whole room. They'll call it the server room. And all of the maintenance for those servers is then on that company. And then you've got the added risk or the security risk of, what if there's a fire? What if there's an electrical surge? What happens to all of your data then? Snowflake and other cloud-based sort of serverless solutions, they basically allow a company just to wash their hands of that responsibility, don't have to have all of this hardware or all of this risk and all of this extra money involved with actually in the first place buying the hardware and then actually maintaining it and keeping it going. And actually with Snowflake, you don't actually have to even worry about installing any kind of software at all. It's completely run through the browser. So as you can see here, this is just a screenshot of a Google Chrome instance where I'm just running Snowflake using SQL. So yeah, really, really nice and easy and sort of takes away a lot of the issues you have there. I think the other big thing that's worth thinking about with Snowflake is around not having to actually set a computational limit. Let's go back again 30 years, maybe 20 years, I don't know. A company wants to move their data into a database. They want to buy a load of servers. And then they really want to think about kind of the computational limits. They basically need to know that their database or their servers are never going to be overrun or overused and have any period of downtime, because that period of downtime can be incredibly expensive and not just financially to companies. So let's take this bar chart I've kind of knocked up in Tableau. You've got your timer on the bottom, these are your hours in the day. And on the y-axis, you've got your activity. Let's think of that as like your CPU usage or the amount of power your servers are going to need to actually keep itself going. So you can see here at kind of 3 o'clock, this is when the majority of your clients or your employees, I should say, are kind of online. They're all pulling data, they're all kind of using your resources. So that's your peak activity. And when a company was thinking about buying their servers, they're always having to think about that peak activity because it can't afford that period of downtime. So actually, what you'd probably do is go ahead and buy enough servers to allow your CPU usage to be actually higher than your peak activity, because you never know if you might actually go more on a certain day. And what that means is when people go home and go to bed and they're no longer requiring the CPU, you're actually essentially paying for what's actually more than your peak activity for times that you really, really don't need it. So all of this CPU usage is essentially, you could say, wasted money. You're not able to scale up or scale it down in any sort of real time. Let's say you hired 25 more employees and suddenly your peak activity flies up. Then you need to buy even more servers. Then you need to improve your hardware, and that's an expensive process in itself. What about if you've not got enough space in your server room, for example? What Snowflake allows you to do is not have to worry about setting this higher limit or lower limit. It actually scales up and down really dynamically based on the CPU usage. So as you can see here, this would be like a Snowflake model. It gets to about 8 o'clock and people start to log in. The Snowflake will notice the increase in CPU demand and essentially spin up another compute cluster. It will create more CPU supply, essentially. So when it gets 9 o'clock again, it scales itself up, it keeps on going. It keeps on going up, it keeps on giving you the amount of CPU usage you need to function, essentially. And when it gets to lunchtime and people start to log off, it will scale itself down almost in real time. And that will just go on throughout the day. So you don't end up in a situation like this where you're essentially paying money for nothing. This is kind of one of the big selling points of Snowflake. And this is where we can start to think about how Snowflake charges you. So whenever the CPU is used, it spends what Snowflake calls Snowflake credits. So the more CPU usage, the more credits you spend. And that's the way it works. So essentially, you're only then paying for what you're using. That's that kind of pay-as-you-go model that I kind of alluded to earlier. Here, you're always paying for the same amount of usage. Here, you're paying for exactly what you use. And that is that attraction of Snowflake. That is why businesses are starting to turn to it. It's fully scalable. It's certainly worth then thinking about Alteryx and Tableau. If you're looking to leverage Snowflake alongside these products, there are certain things we can think about that could really make sure we're not being inefficient with our kind of the way we're using it and wasting money, essentially. So starting with Alteryx, I've got some Alteryx points, I've got some Tableau points. I might even jump across really either, because a couple of these points kind of relate to both. But with Alteryx then, first point is don't be afraid of that run button. So when we're running a workflow, you know, anyone who's built an Alteryx workflow knows that you're going to be hitting that run button quite a lot. Because the big thing about Alteryx is you're able to see previews of your data between every tool. So you put a tool down on the canvas, you hit run, and you think, oh, let's see what that did to the data. It can be easy to think that every time you hit that run button, you're getting your warehouse to spin up, which is then causing CPU requirements, which is then spending Snowflake credits. Well, that isn't the case with an asterisk. What Snowflake has, one of its native features, is what they call the result cache. So this is essentially what it sounds like. Every time you run a query, Snowflake will store that query in its cache. So it basically means that the result comes back a lot faster, but also means that it won't actually require the warehouse to start to kind of spin itself up and go again. It's just it's a much faster and much more cost efficient way. So every time you hit that run button, as long as you don't change the query, and that is the key point to underline and take away, as long as that initial query doesn't change, you won't be charged again. The warehouse won't have to spin up and spend any credits. So what I mean by that, if I take us into Alteryx in just a second, just got a little workflow here that we'll be coming back to. Our initial query would be connecting to Snowflake, and there are loads of content out there about how you connect to Snowflake using Alteryx. But essentially, your query in this instance might be to select a table, hit all, and hit OK. Any tool you put after that isn't changing that query. That query in the first place is staying the same. So every time you hit run, it will just be pulling it from the result cache. If you decide you need to change your query, maybe you want to go in and actually say, I only want date and region name in this example, you hit OK and then hit run, hit OK and then hit run. Well, that will change the query. So that means the result cache will be cleared, the warehouse will be spinning up again, and you will be spending Snowflake credits. So don't be afraid of the run button. It won't charge you every time you press it unless you change that query. That's kind of the key point on this one. The next thing I was going to talk about was auto suspend. So auto suspend, what is it? We'll go back into our Google Chrome instance and we'll have a look at our warehouses. And you basically can see here, each warehouse has this thing called auto suspend. And basically what that means is if the warehouse is not being used, or it's not being called, it's not required any kind of CPU usage, it will, like it sounds, go into this state of suspension. So you can see here, this one here is suspended. That means it's stopped. That means it's not using any Snowflake credits. It's not charging you as a customer. What we can actually, and the temptation of that is, oh, okay, great. So this sounds like we want to do this as quickly as possible. So what you can actually do in the SQL kind of terminal is you can go in and you can set your auto suspend. So you can go auto warehouse. You can select a warehouse. I'm going to select that one you saw called bad practice. That was just a warehouse I set up to try and do as many bad practices as possible to show you, how you can quite quickly spend a lot of Snowflake credits. But we're going to basically say, we're going to say set auto suspend spell equals, let's just say 1. Remember it was 10 minutes before. We'll hit run. I must have spelt suspend wrong. I absolutely did. We'll hit run again. So that statement's executed successfully. If we now go back to our warehouses, we can see now for our bad practice, we've got this auto suspend of 1 second. This might seem like a really, really good idea. It might seem that, every time Snowflake, every time we stop using the database, it's going to very quickly, basically stop itself and stop charging you credit. However, the big issue with this is that every time a sort of a warehouse needs to start working again, every time it needs to spin itself up, that actually does charge some credits. Snowflake will charge you per per second billing. However, if a warehouse was active for less than 60 seconds, it will always round itself up to 60 seconds. So if you've got a warehouse that was active for 5 seconds, a query took 5 seconds, Snowflake will actually round that up to 1 minute. So it isn't, and actually the performance hit for Snowflake to actually spin up that warehouse is actually quite expensive. You really will notice the time it takes for that warehouse to actually start itself before then it runs the query. And there's always that balance between wanting to be cost efficient and actually wanting to have good performance. The next thing I wanted to talk about was using SQL in Alteryx. So if we go back to our Alteryx workflow again, here we are. We've got 2 examples, 2 input tools, both exactly the same, both connecting to exactly the same table. With this one, I've basically downloaded this house prices data set online, only taken sort of 6,000 records. And essentially, I just wanted to give you an example of how we can kind of basically do the same thing, but using SQL. So essentially here, what I've done is I've used an input tool, and all this has done is effectively taken all of the data. So you can see here, I've ticked the asterisk star button at the top, which basically is like if you know SQL, that just basically means select all from this table. So that's what we've done here. Then we can see we've used a select tool just to have a look at our data. I've actually changed average price to be a double. And then what I've done is I've decided, okay, I would like to know what the average price is per region. Forget about the date. So we can actually see here that we've now got, for each region, we've got the average price across the whole data set for each region. So what we've actually asked Snowflake to do is go into the database, pull out all of the data, and then do a group by. If you know SQL, that would be a group by. What is a lot quicker and a lot more cost efficient is to actually do that kind of SQL in the back end. Write some custom SQL to basically tell Snowflake to not go in and have to take all of the data, but select region name. So instead of basically going in and taking all of the data, we're saying I only want these first 2 columns. I want region name and I want the average price from the table that we've already seen in the query builder, and then do a group by on region name. So essentially, we've done exactly the same thing as these 3 tools in one tool, and required a lot less CPU in the first place. That is going to basically take a lot less time. It's going to require a lot less data to come out of the database, all of which is going to cost us less money further down the line. So if there are ways we can start to think about using group by or where clauses or even a limit clause, really do take that opportunity, because essentially it's all about reducing the CPU demand on Snowflake. And if we need to take less data, that will be much less demand. So the next tip is using the record limit. I have to say, this one could easily confuse for a sample tool. So I will take you into Alteryx again and show you where you find the record limit. See a little bit of a hidden one, you could say. So essentially, again, same thing. We've now got our Snowflake kind of connection sorted out with an input tool. And when we click on the input tool, you get the configuration pane for that input data tool. And you'll see actually the very first option is that record limit. And I've just set it to 10. And basically that is exactly the same thing as, you can actually look at the SQL here. If we go into this thing and look at the SQL editor, it's exactly the same thing as saying limit 10, except we're basically doing this from the front end. So if I can actually type the word 10, we're actually doing that from the front end. So essentially what that's saying to Snowflake is select all from this table with a limit of 10. So it'll only bring back those 10 records. If we're developing a workflow, there's every chance that we're not going to need all of the data for that workflow development. And what the easy mistake to make would be using a sample tool instead, where you're only taking the first 10 rows. Ignore the state of that data. It's just how it is. But yeah, if you were to use a sample tool, then essentially when you hit run, you're basically telling Alteryx to bring in all of the data and then cut it down by 10. So you're still requiring that same level of workload. So we've explored some Alteryx options. Next, let's start to think about Tableau. And actually, the first thing I think I'll tell you about is actually custom SQL. So we spoke about custom SQL in Alteryx, exactly the same concept in Tableau. So for those that aren't aware, I'm just going to basically load up Tableau here. Let's connect to a completely new data source. You can see I've been kind of playing around with a few here, but we'll connect to a new data source. We can see Snowflake in our list of different servers. So we'll hit Snowflake. Sign-on's fairly simple. You need to basically tell it the server location, which is the same one you'll find in the browser, and then your username and password. So I will go ahead and sign in. When you then get into the data source pane, you will see down the left-hand side, firstly, the select warehouse. I'm going to go ahead and choose my bad practice warehouse. That's my large warehouse. This is the one I'm happy to, trying to kind of like do some bad practices just to kind of show you guys how you can, quite quickly build up some credits. We'll get to that at the end of the video, but we're going to go into our saving money demo. We're going to basically do exactly the same thing that we did in Alteryx, but really show you how to do it in Tableau as well. So exactly the same thing here. We can go into our new custom SQL, double click it, and this time we can, I'm just actually going to pull this out so I don't get the wrong name. Hit new custom SQL. So I'm going to go select all from, and we could say house prices shortened limit, and again let's just do a limit of 10, and that'll be absolutely fine. So that effectively, we hit preview results, didn't work. House prices shortened. It didn't like my, oh there you go, didn't like my semicolon. So there you are. Don't do semicolons in Tableau. but yeah, essentially exactly the same concept. We are now limiting what we're bringing in by using custom SQL, or we could go back in and we could maybe do a group by. So instead of limiting it, let's do select the region name and the average price from a house price is shortened, and we'll do a group by region name. No semicolon. Exactly the same thing as Alteryx, and this time again, just thinking about that CPU load and how much less demand that's going to require than doing a select all. So if you know that you're only going to require a subset of data or data in a certain way, cool. So next point is around using extracts. So for those of you that are new to Tableau, you have the option to connect to your database and keep your connection as live or as an extract. Now, if you use a live connection, then every single time a user hits a filter or changes the dashboard in some way, that will send a query to the database. So a warehouse will have to be spun up if it's already suspended. It will then have to carry out that query, pull the data, then bring it into Tableau. Obviously, that can be a very, very quick process. It probably will be 1 or 2 seconds, depending on the size of the database. However, that is going to cause, Snowflake credits to be spent over time. That is going to have a CPU demand on the database. If you were to create an extract, you basically create a snapshot of the data, and every time that user then queries the data, it only looks at that kind of local table that we've built. It doesn't have to go back to the database every single time with this new query that you might have for it. So that's a really powerful way. You can then set extracts to refresh over time. So you don't have to worry about your data being old. Obviously, the big benefit of live data is that any change in the database will be seen straight away. But with an extract, you can have it refreshing every day, every hour, every minute, which is actually our next point, which is using incremental refreshes. So we've got a screenshot of it here. I think I'll take you into Tableau to show you this in action, just to show you exactly how to do it. But quickly, what an incremental refresh is instead of then taking that extract and doing a full refresh, which means you'll have to basically take a snapshot of the whole database again. If you've got a database that has 100,000 rows in, you're going to have to ask if you've got your database refreshing every sort of hour, every hour your data source is going to have to be completely refreshed and another 100,000 rows pulled out of Snowflake. Again, think about the CPU demand. What an incremental refresh will do is essentially you point it to a certain column. So in this sense, it's date. It will look at that column and it will only find data after the most sort of the latest data is found in the last refresh. So for example, let's say we had data going up to the 1st of August on our last refresh, on our last full refresh, on our last extract. It will only then bring in data that's from the 2nd of August or the 3rd of August and so on. You can ask Tableau to do a full refresh every 2 weeks, every week, which we would always recommend, because there might be times that the database did change from dates previous to your max date from your previous refresh, but an incremental refresh is basically going to ask Tableau to bring in less rows as a whole. So next point for you, just a couple more to go. The next one is to hide all unused fields. So you might have seen this in that pop-up window when we looked at the extract data last time. So if I go back into Tableau for you, and this time I'm going to right-click on this bad practice data source and go into extract data. And you'll see here this hide all unused fields. So we can basically see, don't worry about all this stuff ahead, this is me just playing around, but we can see this option to hide all unused fields. And basically what that means is, let's say we've created our visualizations, we've created our dashboards, we know we're not going to make too many more changes, and we're happy to upload, and we want to make an extract of our data so that it's nice and fast on the server, and we're not obviously using too much CPU demand or computational demand, so it's costing us less money. But there might be some fields on this left-hand side that we haven't actually used. So if we tick this button here, hide all your unused fields, and hit extract, what that will do is actually hide any fields that we haven't used in the data source. If we didn't click that, we're essentially asking every time we do an extract, every time we do a refresh of the extract, we're asking Tableau to go away and bring back data that we're actually never going to use. So that hide all your unused fields button can be really, really useful. And again, it's all about making our Snowflake use as efficient as possible. Why would we want to spend credits on bringing back fields that's we're never actually going to use, at any point? The last one is actually around using Snowflake usage dashboards. So this is a screenshot of one I've taken from Tableau's website itself. You can essentially download these workbooks and connect directly to your Snowflake instance. And what this will effectively do is look at your Snowflake data and produce exactly the same dashboards. And it can basically allow you just to do some analysis on how your company is using Snowflake. You can see which the most expensive warehouses are. You can see when you're spending the most money. Maybe you might have a really scary looking spike on a Sunday at 4 a.m. that shouldn't be happening. It can really help you isolate a potential process that may have been mistakenly made. So that can be a really powerful tool to use. And again, Google Snowflake usage, and Tableau themselves have dashboards that you can go on and download and basically connect straight to your Snowflake account. So that could be a really nice way to kind of spot some wastage, really. So very last thing we're just going to very quickly discuss, and congratulations to those that have made it this far, is really how you can access the Snowflake console to kind of keep track of some of your usage. Obviously, we've talked about Tableau dashboards, but there is actually a way to look on the actual console itself, and I'll just show you that. And I think crucially, what I've done here is I've created what I've called a bad practice warehouse, and this compute W8, that's like my default warehouse. This one I've tried to be really kind of disciplined, and I've tried to follow some of the kind of good practice that we've discussed. And on this one, I've purposely done like full refreshes and not set any record limits. I've created a few workflows that push data to the server. I've kind of gone on to Tableau and uploaded these workbooks as data sources and done all sorts of bad practice on them. All of the things that we've discussed in this video I've done. But really, how can we do it? So if you're on your default sysadmin role, you won't see the account button that we're looking for here. So what you want to do is go to switch role and click into account admin if you have that that role available to you. When you change onto that, you'll suddenly see this account button become active. When you then click onto that, that's when then you can look at your different warehouses. Ignore some of these ones. This was me just playing around in the past, but the ones that we're interested in is bad practice one. So you can see on the same day that I'm recording this, I've used 11.5 credits, and this is because I've been doing things like full refreshes. I've been developing workflows without any record limits. I've not used any custom SQL. On this compute warehouse one, you can see I've done exactly the same processes. I've used exactly the same dashboards, except this time I've done incremental refreshes. This time I've been setting record limits when I was developing the workflow. And you can see I've used an absolute fraction on the same day here. So this is something to be aware of. Go to account and go to usage. You can always keep track of how many credits you've used. But then if you want to go a step further, there's actually this resource monitor section as well. This is where you can actually set limits. So you can basically set a credit limit for different people. And essentially that will allow you to monitor certain warehouses and say, actually, I don't want them to be allowed to spend more than X amount of credits or a % amount of credits. And this can be a really good way to kind of just not necessarily keep track of your employees, but just really make sure that, especially if people haven't been using Snowflake for long, this can be a good way just to make sure that we're not, pointlessly wasting money in the business. So resource monitors can be a really good thing to do as well. And really the last thing to say is thank you so much for listening. We've had a real quick tour. We've discussed, a little bit about databases. We've talked about Snowflake's kind of unique architecture. We've talked about how they then charge their customers. And then we've looked at Alteryx and Tableau and how we can leverage those products to make sure we're being as efficient as possible. We really have just scratched the surface on some of those topics. Be sure to check out our channel to see some other content around Snowflake, around Tableau, around Alteryx. I've also written a blog on this subject as well, which goes into a little bit more detail on some of these topics too, and has some extra tips that really I didn't have time to discuss on this one.